parkour or die. Having survived a Tide Pod challenge, Foolio decides to do a parkour jump between two buildings separated by 6 meters. Foolio's typical run has been measured to be about 4.25 meters per second. Can Foolio make the jump? Step 1, if it's not in the classroom, where did that number come from? How did Foolio get his speed? You must ask that, because sometimes people lie or they didn't know what they were doing with the device. So step 1, we need to identify the numbers that govern this problem, but we also have to be skeptical about that value someone's reported to us. Right? It is always possible you were given bad data. And we're not going to worry about Foolio's body shape. It doesn't matter that his feet are out here and then he's hanging from his hands. We're just going to treat him like a ball bouncing down. What is the key here? The key is exactly like the bomber, except Foolio is the bomb, in his own mind at least. When he jumps, his horizontal speed will just continue exactly like he was a bomb, but he will begin to fall. And by the time he's fallen to an altitude lower than the next building, he's done for. This will be the formula that governs him, exactly like the bomber. We rearrange and we get 1.42 seconds. Now what if we did Collatti's rearrangement and I let you do this? 1.41 seconds. That's the only change, 100th of a second using my estimation. And I was able to do it in my head because I'm old, I have no social life, and I know the square root of 2 is 1.41. We continue. We'll use my rounded time and the time where we didn't round gravity and see if it makes a difference to the answer. Foolio, we multiply his speed that he's running times the time that he has, and we get 6.035 meters. He just barely to 3 centimeters make it. That's the length of his fingers. And if we use my speed from rounding, we get 5.99.3. This means that in this case, my rounded number may actually change the answer from yes to no. If all we had to do is exceed 6 meters, then according to this, using accurate numbers, 9.8 for gravity, he made the jump. Using a rounded value, he did not make the jump. But in reality, dude, you're gonna die if you try this jump. So as a textbook question, it's quite clear if you use proper numbers, he made the jump. So here is my rounding causing a problem. Your yes-no answer would be messed up. Almost like I deliberately set it up to appear that way. But these are not the real world conditions. We have to look at these numbers in the real world to actually go, does Foolio have even the remotest chance of making this jump? Let's suppose Foolio used a police radar gun to get the speed he ran. Those police radar guns are plus or minus 2 kilometers an hour. How do I know that? Just Google it. Just pick an instrument and go, what is the accuracy or precision of this device? You'll be surprised to find out how inaccurate many devices are, even though they have lots of decimals on their display. And this is just the instrumentation to use. Right? We got 0.5 meter a second on the instrumentation alone. But how consistent is Foolio? Let's suppose he wants to measure his running time on some event, and he gets 30. You know, I know this says like 29 in here. Let's call this 30. And he consistently runs the time in 30 seconds, and you notice very little drift from that time. But what if Foolio's running speeds have been mapped out like this? You get an average here, but you might go, dude, you're really slow a lot of the time. You don't consistently come in at the speed necessary for the jump. That's real world, and that could make all the difference in this being just luck that he makes it. So when people say we calculated, and I'm like, no, you calculated it was at work, but you were just bloody lucky he made the speed today, because he's quite frequently not running that speed. And this is the part of error analysis that takes thinking. Like the poor stuntman that thought because he timed the burn of a rope once, he would get that time every single time he tried. So let's build in Foolio's error from the police radar gun. We're going to take a speed and add to it the error of the radar gun and subtract, run the problem again, and see if he consistently at the range that instrument recorded, if we're safe. So Foolio might have been running 3.7, he might have been running 4.7. And if we put those numbers in, he'd be Foolio now, brah. At the lower speed range, he isn't even going to come close to making the jump. So he'd be Foolio. But another problem comes in. If he succeeds in actually running faster, he could jump almost 7 meters, but dude, he's Flatio now. He's going to be injured. And why I say he be Flatio? Simple. Everybody thinks that when you run horizontally, you magically defy gravity. You run off this, you start plunging. And you might go, well, I don't know, maybe if he really ran fast enough. If I shove the two buildings together and say, hey, you want to jump 10 meters? You saw what happened to that girl when she jumped like 2 meters. And she landed with her legs out and buckled at the knees immediately, and she still broke her legs. She didn't land straight-legged. She collapsed like you would expect, and she ruined her legs for life. So this is a 10-meter fall. You're not walking away from it. We go, how fast is he actually going to hit? He hits at 50 kilometers an hour. Just try to imagine your parents are driving down the street at regular street speed and you leap out directly into a telephone pole. You're not walking away from this. With really careful landing technique, when he jumps, he's actually going to be traveling faster than 14 meters a second because he's adding his running speed to the drop. And that puts him at like just a smidgen over. He might tumble and roll. But all the records I've looked up, nobody has done a parkour jump higher than 7 meters without injury. And that girl only jumped like 3 meters, and she will never walk properly again. And even if she gets 20 good years on her legs, when she gets to be my age, those injuries are going to come back.